Hello, in this lecture we will answer on two questions. In the first question, we'll find out the side length of square ABCD, and in the second question, we'll find out the length of line segment AD that is equal to x. So we'll start with the first question. Here in the drawing we have square ABCD. We know that the short line segment DE equals to 1 unit. Inside this square we have this circle, and we know that the radius of this circle is equal to 2 units. And we want to find out the length of one side of square ABCD. So first of all, we'll define the side length of square ABCD as x. That is to say, here the length of side AB equals to x according to our definition. The length of side DA of square ABCD, it is also equals to x according to our definition. The length of side DC of square ABCD is also equals to x. According to our definition, of course. And the length of side BC or CB of square ABCD is equal to x. Okay. In the next step, I will present to you a rule that I have already mentioned in the past. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. Again, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here we define the center of this circle as O. We define the point of tendency of tangent AD with this circle as M. We define the point of tendency of tangent AB with this circle as L. And we define the point of tendency of tangent EB with this circle as Z. So OM, it is the radius of this circle that is equal to 2 units, according to what is given as the question. Because of the fact that line segment OM starts from the center of the circle and ends at point M, it is defined as a radius. So we define the radius of this circle as R, and according to what is given as the question, R equals to 2 units. So here we have the radius MO that is drawn to the point of tendency. That is to say, the radius OM, it is drawn to point M, that is the point of tendency of tangent AD with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent AD will be perpendicular to the radius MO. So AD is perpendicular to MO. That is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 1. In the next step, we join points O and M together by a straight line. O is the center of the circle, L is the point on the circle itself. This is exactly the definition of a radius, that is to say, OL is the radius of this circle that is equal to 2 units according to what is given as the question. So here again we have the radius OL that is drawn to the point of tendency, that is to say it is drawn to point L, that is the point of tendency of tangent AB with this circle. And whenever we have a radius that is drawn to the point of tendency, then the tangent AB will be perpendicular to the radius LO. So AB is perpendicular to LO, that is to say this angle equals to 90 degrees. This angle will also equal to 90 degrees. Okay, according to rule number 1, of course. And we know that all the angles inside the square are right angles. That is to say, angle BAD is a right angle because ABCD is a square. Okay, so actually in quadrilateral OMA, in quadrilateral OMAL, we have 1, 2, 3 right angles. Okay, write it down. In quadrilateral OMAL, we have 1, 2, 3 right angles. The sum of 3 right angles is 90 degrees times 3 is 270 degrees. Plus the size of the fourth angle, that is actually angle MOL. So actually in total the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay, so here the sum of 4 angles in quadrilateral OMAL must be equal to 360 degrees. Here we subtract 270 degrees from this equation, and we get that the missing angle MOL is equal to 360 degrees minus 270 degrees, it is equal to 90 degrees. So angle MOL is a right angle, it is equal to 90 degrees. So actually we found out that all the 4 angles inside quadrilateral MOL are right angles, and therefore quadrilateral MOL that has 4 right angles must be at least a rectangle if not a square. So we relate to quadrilateral MOAN as a rectangle. I write it down. Quadrilateral OMAN is a rectangle. Quadrilateral MOAN is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. So a rectangle MOAN, its opposite sides, they are equal to each other. That is to say, MO equals to AL. MO equals to AL. But we already found out that MO equals to 2 units. It is the radius of the circle. So we can write here that MO equals to 2 units. And from this equation 2 equals to MO equals to AL, we will derive that AL is also equals to 2 units. AL equals to 2 units. So you can write down here that AL equals to 2 units. Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, we will get that MA equals to OL. MA equals to OL. But OL equals to 2 units. It is the radius of the circle, so we can write here that OL equals to 2 units. And from this equation MO equals to OL equals to 2, we will derive that MA is also equals to 2 units. And here MA equals to 2 units. So actually we found out that all the sides of quadrilateral MOAL are equal to each other. They are all equal to 2 units. Therefore quadrilateral MOAL is not a rectangle but a square. So write it down that quadrilateral MOAL is a square. In the next step I will present to you rule number 2 that I already mentioned in the past. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. I repeat again, the lengths of two tangents from a common external point to a circle are equal. So we'll focus at point E, that is the common external point, in relation to this circle. From the common external point, point E, we have two tangents to this circle. The first tangent is tangent EM. And the second tangent is tangent EZ. And according to rule number 2, the lengths of those two tangents equal to each other. That is to say, EM equals to EZ according to rule number 2. Okay. What is the length of tangent EM? From the drawing, it is very easy to say that the length of tangent EM, it is equal to dA minus dE minus MA. I repeat again, the length of tangent EM equals to dA minus dE minus MA. So EM equals to dA. dA equals to x according to our definition, minus dE. dE equals to 1 unit according to what is given as the question, minus MA. MA equals to 2 units according to what we have already found out. So in conclusion, we found out that EM equals to x minus 1 minus 2. That is to say, EM equals to x minus 1 minus 2 is x minus 3. So EM equals to x minus 3. So we can write here that EM equals to x minus 3. Actually, according to rule number 2, we found out that EM equals to EZ. But according to what we just right now found out, we found out that EM equals to x minus 3. EM equals to x minus 3. So from this equation, x minus 3 equals to EM equals to EZ, we will derive that EZ is also equals to x minus 3. EZ equals to x minus 3. So I can write down here in the drawing that EZ equals to x minus 3. In the next step, we will focus on the common extra point, point B. Here, the common extra point, point B. So, here, from the common extra point, point B, we have two tangents to this circle. The first tangent to this circle from point B is BL, and the second tangent to this circle from point B is BZ. And according to rule number 2, the lengths of those two tangents must be equal to each other. That is to say, BL equals to BZ according to rule number 2. Okay, what is the length of tangent BL? From the drawings, it is very easy to see that the length of tangent BL equals to BA minus LA. Again, BA minus LA equals to BL. BA minus LA equals to BL. That is to say, BL equals to BA. BA equals to X according to our definition. And we have already found out that LA equals to 2 units. So in conclusion, we found out that BL equals to x minus 2. BL equals to x minus 2. So we can write down here that BL equals to x minus 2. But according to rule number 2, we have already found out that BL equals to BZ, and we just right now found out that BL equals to x minus 2 also. So BL equals to x minus 2. And from this equation, x minus 2 equals to BL equals to BZ, we will derive that BZ is also equals to x minus 2. BZ equals to x minus 2. can write down here that Pz equals to x minus 2. In the next step, we'll find out the length of line segment EA. From the drawing, it is very easy to see that the length of line segment EA it is equal to dA minus DE. Again, dA minus dA, dA minus DE equals to EA. Again, dA minus DE equals to EA. So here EA equals to dA minus DE. So EA equals to dA equals to x according to our definition, and dE equals to 1 unit according to what is given us in the question. So in conclusion, we found out that the length of line segment EA it is equal to x minus 1 unit. So in the next step, I'll copy the right triangle EAB in this new pattern. We will implement the Pythagoras theorem on the right triangle EAB. So just right now found out that EA equals to x minus 1. And we already found actually AB equals to x according to our definition. And what is the length of the hypotenuse EB? The length of the hypotenuse EB it is equal to x minus 3 plus x minus 2. So the hypotenuse EB equals to x minus 3 plus x minus 2. X plus x is 2x, and minus 3 plus minus 2 is minus 5. So in conclusion, we found out that EB equals to 2x minus 5. So we will implement the Pythagoras theorem in this triangle EAB. So in triangle EAB, by PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AB, so the square of the hypotenuse is AB squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to EA squared plus AB squared. So here EB, the hypotenuse EB equals to 2x minus 5, so we substitute EB by 2x minus 5. If EB equals to 2x minus 5, then EB squared will be equal to 2x minus 5 squared. That is equal to EA squared. EA equals to x, so EA squared equals to x squared plus EA is actually AB square. AB equals to x. Here AB equals to x. Therefore AB square will be equal to x square plus EA square. EA equals to x minus 1. Therefore EA square will be equal to x minus 1 square. So in conclusion, we found out that 2x minus 5 square equals to x square plus x minus 1 square. Here we'll use the algebraic identity that a minus b square equals to a square plus b square minus 2 times ab. According to the algebraic identity that I mentioned, 2x minus 5 square will be equal to 2x squared, that is 12x squared is 4x squared, plus 5 squared, that is 25, minus 2 times 2x is minus 4x, and minus 4x times 5 is minus 20x. And here we found out that according to equation number 1, 4x squared plus 25 minus 20x equals to x squared plus x minus 1 square. X minus 1 square equals to x square plus 1 square, that is 1, minus 2x. So in this end of equation number 1 we have four x squared minus 20x plus 25. This is equal to x squared plus x squared is 2x squared minus 2x plus 1. So here we subtract 2x squared from this equation, equation number 1, and we get that 4x squared minus 2x squared is 2x squared. We'll also add 2x to this equation, equation number 1. 2x minus 2x is 0, and minus 20x plus 2x is minus 18x, plus we subtract 1 from this equation, 1 minus 1 is 0, and 25 minus 1 is 24. That is equal to 0. So here we got the quadratic equation that 2x squared minus 18x plus 24 equals to 0. Here we divide this equation, equation number 1 by 2, and we get that according to equation number 1, 2x squared over 2 is x squared, minus 18x over 2 is minus 9x, plus 24 over 2 is 12, and 0 over 2 is 0. So actually, we got here the quadratic equation that x squared minus 9x plus 12 equals to 0. In this quadratic equation, the coefficient a equals to 1, the coefficient b equals to minus 9, and the coefficient c equals to 12. And the general formula for solving out any quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. So here x equals to, we'll put the data inside the general formula and we'll find out the value of the values of x. So x equals to minus b, b equals to minus 9, so minus b is minus 9, that is plus 9, plus minus square root of b squared, b equals to minus 9, so b squared is minus 9 squared, that is 81, minus 4 times a is 1, times c is 12, over 2a. A is 1, so 2 times 1 is 2. So x equals to 9 plus minus square root of 81 minus 4 times 8 is minus 48. So it is 81 minus 48 over 2. So x equals to 9 plus minus, inside the root we have 81 minus 48, 81 minus 48 is 33, so we left only with 33 inside the root, over 2. So here we will have two solutions that are possible for x. The first solution for x is that x equals to 9 minus square root of 33 over 2. 9 minus square root of 33 over 2 is 1.62. So we found out that x equals to 1.62 units. So here x, AB equals to x, so this is x, and x is greater than AL. It's very easy to see that x is greater than AL, and AL itself equals to 2 units. And x is greater, so x must be greater than 2 units. S must be greater than, x is greater than AL, that is equal to 2 units, that is to say x is greater than 2 units. But according to the first solution to the for x, we found out that x equals to 1.62, that is less than 2 units. So, because of the fact that x must be greater than 2 units, and in the first solution x is less than 2 units, we will cancel this solution. This is incorrect solution. We are left only with the second solution, that x equals to 9 plus square root of 33 over 2 units, or in terms of numbers it is 7.37 units. Okay, so I'll repeat again. The answer to the question is that the side length of square ABCD, it is equal to either 9 plus square root of 33 over 2 units, or in terms of numbers, it is equal to 7.37 units. Okay, that is to say AD equals to DC equals to CB equals to BA equals to 7.37 units. Okay, we finish with the first question. In the next step, I will present to you the second question, and we'll solve the second question in two different methods. Okay? In the drawing, we have triangle ABC. We know that side DB equals to 2 units, side AB equals to A units, side AC equals to 2A units, angle BAD equals to 60 degrees, and angle DAC also equals to 60 degrees, and we want to find out the length of side AD that is equal to X. Okay? So first of all, I'll present to you the angle bisector theorem that I've already mentioned in the past, so we'll do it quickly. The angle bisector theorem is true in any triangle. So we have here triangle ABC that could be any triangle. This is triangle ABC. And in triangle ABC we have the angle bisector AD. AD is the angle bisector. Why AD is the angle bisector? Because of the fact that it divides angle BAC into two halves. Each half equals to theta. Okay, so if I want to that AD is the angle bisector, so whenever we have the angle bisector in any triangle, then we can implement the angle bisector theorem. According to angle bisector theorem, the following equation is true. Here, that AB over AC equals to BD over DC. Okay? AB over AC equals to BD over DC. We can implement the angle bisector theorem in our triangle ABC. Why we can implement it in triangle ABC? Because of the fact that 9 segment AD that is equal to X, it is the angle bisector in triangle ABC. It divides angle BAC that is equal to 120 degrees into two halves. The two halves, each half equals to 60 degrees. Therefore, AD is the angle bisector. For that reason, we can implement the angle bisector theorem in triangle BAC, in triangle ABC. So, according to the angle bisector theorem in triangle ABC, we get that AB over AC equals to BD over DC. Okay? Repeat again. In our original drawing, we have triangle ABC. The implementation of angle bisector theorem in triangle ABC means that AB over AC equals to BD over DC. Here AB equals to A, so we substitute AB by A. Over AC equals to 2A, so we substitute AC by 2A. And it is equal to BD equals to 2 units, so we substitute BD by 2. over DC. DC is the missing line segment, so we leave it as it is. So in conclusion, we found out that according to equation number 1, A over 2A equals to 2 over DC. We have A in the numerator and A in the denominator, so A will get cancelled. So in this side of equation number 1, we have left only with 1/2 that is equal to 2 over DC. Here we will cross multiply this equation, equation number 1, and we get that according to equation number 1, DC equals to 2 times 2. That is to say, DC equals to 2 times 2, that is 4. So here we found out that DC equals to 4 units. In the next step, we will do a construction. We will extend side AC of triangle ABC by a straight line. And from point B we will raise perpendicular to the extended CA. So this angle equals to 90 degrees according to our construction. We will define the touching point of the perpendicular define the touching point of the perpendicular from point B, the extended CA, as E. I repeat again that angle AEB is equal to 90 degrees according to our construction. So I'll write it down here. And angle AEB is equal to 90 degrees according to our construction. Okay. Line segment CA is one side of triangle ABC. Okay, so CA, if it's a side of a triangle, it must be a straight line. It is absolutely a straight line. And when we extended the straight line CA by a straight line, the result is CE. So the result, that is CE, must be also a straight line. Why? Because when you extend a straight line by a straight line, the result must be a straight line. So you can write down that line segment EC is a straight line. Because when you extend a straight line by a straight line, the result must be a straight line. So EC is a straight line. And we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. I repeat again, the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the lower side of the straight line EC at point A, then the sum of the angles here must be equal to 180 degrees. So we'll focus in the lower side of the straight line EC at point A, the sum of the angles here must be, the sum of the angles there must be equal to 180 degrees. So which angles we have at the lower side of EC at point A? We have 60 degrees. And we have another angle that is equal to 60 degrees And we have also angle BAE, that is the missing angle. In total, the sum of those three angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay? 60 degrees plus 60 degrees is 120 degrees, plus angle BAE. In total, the sum of those three angles must be equal to 180 degrees. Here we subtract 120 degrees from this equation, and we get that the missing angle BAE, is equal to 180 degrees minus 120 degrees, it is 60 degrees. So we found out that the missing angle here, angle EAB, equals to 60 degrees. So in the next step we'll focus on the green right triangle, triangle EAB. On the green right triangle, triangle EAB. We know that cosine 60 degrees will be equal to EA over BA. I'll repeat again. In the green right triangle, triangle EAB, cosine 60 degrees must be equal to EA over BA. So cosine 60 degrees equals to EA over BA, but BA equals to A units according to what is given as the question, so we substitute BA by A. We know that cosine 60 degrees equals to 1/2, so we substitute cosine 60 degrees by 1/2. So 1/2 equals to EA over A. So here we will multiply this equation by A, and we'll get that EA equals to A over 2. EA equals to A over 2. Here EA equals to A over 2. We continue to focus on the green right triangle, triangle EAB. On the green right triangle, triangle EAB, we know that sinus 60 degrees equals to BE over BA. I'll repeat again. In the right green triangle, triangle EAB, sinus 60 degrees equals to BE over BA, so it is equal to BE, and BA equals to A, so we substitute BA by A. Okay, so found out that sinus 60 degrees equals to B over A. Sinus 60 degrees is square root of 3 over 2, so we substitute sinus 60 degrees by square root of 3 over 2, and it is equal to BE over A. Here we multiply this equation by A, and we found out that BE equals to A times square root of 3 over 2. So here we can write down that b equals to a times square root of 3 over 2 units. So in the next step, we'll implement the Pythagoras theorem on the big right triangle, triangle ABC. So copy triangle ABC in the new page and we'll implement the Pythagoras theorem on this triangle, triangle ABC. Okay? So actually this is the right triangle, triangle ABC that is copied from the original drawing. What is the length of side EC? The length of side EC it is equal to 2a plus a over 2. Again, the length of side EC equals to 2a plus a over 2. 2a plus a over 2 is 2.5a, or we can present it as 5 over 2a. We have only found out that EB equals to square root of 3 over 2 times A. And the hypotenuse BC equals to 2 plus 4, that is 6. Okay. This is triangle EBC. So we will implement the Pythagoras theorem on this right triangle, triangle ABC. So here, by PT is the abbreviation for Pythagoras theorem. We will get that according to equation number 2, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is BC. Therefore, the square of the hypotenuse is BC square, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to BE square plus EC square. Okay. So actually BC equals to 6 units, therefore BC square will be equal to 6 squared, that is 36, and it is equal to BE square. BE equals to square root of 3 over 2 times A, so B square will be equal to square root of 3 over 2 times A square plus EC square. EC equals to 5 halves A, therefore EC square will be equal to 5 halves A square. So here we'll open the brackets on this side of equation number 2 and we get that according to equation number 2, 36 equals to square root of 3 over 2a square. This is equal to square root of 2 square is square root of 3 square is 3 over 2 square is 4 times a square plus 5 half a square. 5 halves a square is equal to 5 square, that is 25, over 2 square, that is 4 times a square. So according to equation number 2, we find out that (36) equals to 3 quarters plus 25 quarters equals to 28 quarters times a square So 36 equals to 28 over 4 is 7, so 36 equals to 7a squared. Here we divide this equation number 2 by 7, and we get that according to equation number 2, a squared equals to 36 over 7. Okay, so now that a squared equals to 36 over 7. We take out of this equation number 2, and we get that according to equation number 2, a equals to the square root of 46 is 6 over the square root of 7. So we found out that a equals to 6 over square root of 7 units. In the next step, I will present to you rule number 3, that is connected to diagram sector. According to rule number 3, in any triangle, so actually here triangle ABC, that could be any triangle. And we have here also the angle bisector AD in triangle ABC. And according to rule number 3, because of the fact that triangle ABC, that could be any triangle, in triangle ABC we have the angle bisector AD. According to rule number 3, the following equation is true, that AD squared equals to AB times AC minus BD times DC. Okay, I repeat again, according to rule number 3, because of the fact that we have in triangle ABC the angle bisector AD, the following equation is true, that AD squared equals to AB times AC minus BD times DC. We actually can implement rule number 3 in triangle ABC. Why? Because in triangle ABC we have the angle bisector AD. So I'll copy triangle ABC in this new page and we'll implement rule number 3 in triangle ABC. So actually this is triangle ABC that I copied from the original drawing. AD is the angle bisector that is equal to x. So according to rule number 3, we get that AD squared equals to AB times AC minus BD times DC. Repeat again, triangle ABC, according to rule number 3, we get that AD squared equals to AB times AC minus BD times AC. So AD equals to X, so AD squared is X squared, and it is equal to AB squared. AB equals to A, so AB times AC. AB equals to A, AC equals to 2A, minus BD, BD equals to 2, this equals to 4. So in conclusion, we found out that X squared equals to A times 2A is 2A squared, minus 2 times 4 is 8. So in conclusion, we found out that X squared equals to 2A squared minus 8. So X squared equals to 2, and A squared equals to 36 over 7. So we substitute A squared by 36 over 7 minus 8. 2 times 36 is 72. So I write it down. So we get that X squared equals to 72 over 7. And we multiply minus 8 by 7, and then we divide it by 7 in order to account for this expression. So minus 8 times 7 is minus 56. So here we actually found out that X squared equals to 72 minus 56 over 7. 72 minus 56 is 16. So in conclusion, found out that X squared equals to 16 over 7. Here we'll take out all of this equation and found out that X equals to square root of 16 is 4 over square root of 7. So after we found out, the answer to the question is that here X that is equal to AD, it is equal to either 4 over square root of 7 units, or in terms of numbers, it is equal to 1.51 units. Okay, it's equal to either 4 over square root of 7 units, or in terms of numbers, it is equal to 1.51 units. Okay. Okay, so we finished with the first method. In the next step, I will present to you how to find out the length of line segment AD that is equal to X according to the second method. Okay. In the second method, we define angle ADC as theta. BC is one side of triangle ABC, therefore it is absolutely a straight line. And we know that the sum of the angles on one side of a straight line is equal to 180 degrees. So if angle BDA equals to theta, then angle ADC must be equal to 180 degrees minus theta. Repeat again that BC is a straight line, therefore if this angle equals to theta, this angle must be equal to 180 degrees minus theta, because theta plus 180 degrees minus theta will be equal to 180 degrees, and this is exactly, it is obeys the rules that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay, so in the next step I will present to you the law of sines. We already presented it in the past, so we'll do it quickly. And we will implement the law of sines in triangles ABD and triangle ADC. So what is the law of sines? The law of sines is drawing a triangle. So here if you have triangle ABC, that could be any triangle. The length of side BC, it is actually equal to A units in its length. The length of side AC is equal to B, and the length of side AB equals to C units, that is to say AB equals to C units in its length. Okay, so according to the law of sines, we get here that A over sine A equals to B over sine B, and it is equal to C over sine C. Here capital A is the size of angle BAC, this angle. Capital B is the size of angle ABC, and capital C is the size of angle ACB. Again, A over sine A equals to B over sine B equals to C over sine C. We will implement the law of sines in triangle ABD. In triangle ABD, according to the law of sines, we get that A over sinus theta equals to 2 over sinus 60 degrees In the next step, we will implement the law of sines in this triangle ADC. According to the law of sines, in triangle ADC, here 2a over sinus 180 degrees minus theta equals to DC over sinus 60 degrees. Actually, we have the trigonometric identity that sinus 180 degrees minus theta equals to sinus theta. So actually we can substitute sinus 180 degrees minus theta in this equation by sinus theta. We'll do it now and we get it according to equation number 2. 2a over sinus theta equals to DC over sinus 60 degrees. Okay. So we have, in equation number 2, we have 2 times a over sinus theta, but according to equation number 1, we know that a sinus theta equals to 2 over sinus 60 degrees. So we substitute a over sinus theta in this equation number 2 by 2 over sinus 60 degrees. And it is equal to DC over sinus 60 degrees. So here we have sine of 60 degrees on both sides of equation number 2. Sine of 60 degrees will get cancelled. And what is left from equation number 2 after we cancelled sine of 60 degrees? What is left is actually, here we have only the equation number 2. Uh, 2 times 2 equals to DC. So DC equals to 2 times 2, that is 4. So we can write here that DC equals to 4 units, exactly as we already found out in the first method. In the next step I will present to you the law of cosines that I have already presented to you in the past, so we'll do it quickly, and we will implement the law of cosines in this triangle, triangle ABC. So what is the law of cosines? The law of cosines is true in any triangle. So if we have triangle ABC that could be any triangle, this is triangle ABC. And we know that the angle between side AB and side AC is theta. Side AB equals to A units in its length, and side AC equals to B units in its length, and side BC equals to C units in its length. Then according to the law of cosines, we get that cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. So in any triangle, cosine theta equals to A squared plus B squared minus C squared over 2 times AB. So we'll implement the law of cosines in triangle ABC. So I'll copy this triangle, triangle ABC here. And we'll implement the law of cosines in this triangle, triangle ABC. This is triangle ABC. So this is triangle ABC. That's the copy from the original drawing. AB equals to A, AC equals to 2A, and BC equals to 2 times 2 plus 4, that is 6. Angle BAC equals to 60 plus 60 is 120 degrees. So according to the law of cosines, we get that cosine 120 degrees equals to, here it is AB squared, that is A squared, plus AC squared, that is 2A squared, 2A squared is 4A squared, minus BC squared, BC squared is 6 squared, that is 36, over 2 times AB is A times AC is 2A. Okay? So here cosine 120 degrees equals to minus 1/2. That is equal to 4A squared plus A squared is 5A squared minus 36 over 2A times 2A. Here we have 2 on both sides of the equation, so 2 will get cancelled. We multiply this equation by 2A squared, and we get that 2a squared times minus 1 is minus 2a squared, and it is equal to 5a squared minus 36. Here we'll add to this equation number 3, 2a squared, and also 36 simultaneously. And we get that according to equation number 3, 5a squared plus 2a squared is 7a squared. So 7a squared equals to 46. We divide this equation number 3 by 7. And we get that according to equation number 3, a squared equals to 36 over 7. Okay, so we actually found out that a squared equals to 36 over 7. Here we take out of this equation number 3, and we get that a equals to square root of 36 is 6 over square root of 7. So we found out the value of a. In the next step I will present to you a new rule to calculate the area of any triangle. So if we have triangle ABC that could be any triangle, this is triangle ABC. Angle between side AB and side AC is theta, and the length of side AB equals to A, and the length of side AC equals to B. Then, according to the new rule to calculate the area of any triangle, we get that the area of this triangle ABC, it will be equal to A times B times sinus theta over 2. Again, the area of this triangle ABC will be equal to A times B times sinus theta over 2. We will implement the new formula in our drawing. Here, it's very easy to see from the drawing that the area of triangle ABC, the big triangle, it is equal to the area of triangle ABD plus the area of triangle ADC. So write it down. The area of triangle ABC is equal to the area of triangle ABD plus the area of triangle ADC. Okay. So actually here, according to the new formula, the area of triangle ABC will be equal to A times 2A times sinus 60 degrees plus 60 degrees is 120 degrees, which is times sinus 120 degrees over 2. I'll repeat again that according to the new formula, the area of triangle ABC will be equal to A times 2A times sinus 120 degrees over 2. Likewise, the area of triangle ABD according to the new formula will be equal to A times X, times sinus 60 degrees over 2. I'll repeat again, the area of triangle ABD according to the new formula will be equal to A times X times sinus 60 degrees plus 2 times sinus 60 degrees over 2. And the area of triangle ADC, this triangle according to the new formula, will be equal to X times 2A times sinus 60 degrees over 2. Here, the area of triangle ADC equals to X times 2A times sinus 60 degrees over 2. So here we have 2 on both sides of the equation, so 2 will get cancelled. And we know that sinus 60 degrees equals to sinus 120 degrees equals to sinus 60 degrees. So we have sinus 60 degrees on both sides of the equation, so sinus 60 degrees will also get cancelled. And we have A on both sides of the equation, so A will also get cancelled. So what is left from this equation after we cancelled all the variables? What is left is, in this side we have 2A, that is equal to x plus 2x. So the conclusion from that 2A equals to x plus 2x, so 2A equals to x plus 2x is 3x. 2A equals to 3x. So x equals to 2 thirds times A. And we already found out that x equals that A equals to 6 over square root of 7 units. So we substitute A in this equation by 6 over square root of 7 units. And we get here that 6 over 3 is 2. So here we will have 2 times 2 over square root of 7 units. So in conclusion, found out that x equals to 2 times 2, that is 4 over square root of 7 units. So here x equals to either 4 over square root of 7 units, or in terms of numbers it is equal to 1.51 units. Okay, here x equals to either 4 over square root of 7 units, or in terms of numbers it is equal to 1.51 units. In the next step we will summarize the lecture. We start with the first question. In the first question we have square ABCD. We know that line segment DE, the short line segment DE is equal to 1 unit, and the radius inside the square we have the circle, and the radius of this circle is equal to 2 units, and we want to find out the side length of square ABCD. Well, okay, so first of all we define the side length of square ABCD as x, that is to say DC equals to CB equals to BA equals to AD equals to x according to our definition. Then I presented to you rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius torn to its point of tendency. So here OM is the radius of this circle that is equal to 2 units, so R equals to 2 units. We have the radius OM that is drawn to the point of tendency, that is to say the radius OM it is drawn to point M, that is the point of tendency of tangent AD with this circle, and whenever we have a radius that is drawn to the point of tendency, then the tangent AD will be perpendicular to the radius MO. So if AD is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle will also equal to 90 degrees according to rule number 1. Then we join points O and M together by a straight line. OL is the radius of the circle. Why? Because point O is the center of the circle, and the point L is the point of the circle itself. And this is exactly the definition of a radius. So OL, it is equal to R, that is equal to 2 units. And we have the radius OL that is drawn to the point of tendency, that is to say it is drawn to point L, that is the point of tendency of tangent AB with this circle. Okay, whenever you have a radius that is drawn to the point of tendency, then the radius LO will be perpendicular to tangent AB. So LO is perpendicular to AB, that is to say this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. according to rule number 1. And we know that the angles, all the angles inside the square are right angles. So in square ABCD, angle BAD must be equal to 90 degrees. So actually in quadrilateral MOAL we have 1, 2, 3 right angles. And the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the 4th angle, that is actually angle MOL. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So we subtracted here 270 degrees from this equation and found out that the missing angle MOL, this angle is equal to 90 degrees. So actually we found out that all 4 angles inside quadrilateral MOAL are right angles. Therefore, any quadrilateral that has 4 right angles must be at least a rectangle. So we will relate to quadrilateral OMAL as a rectangle. And we know that the opposite sides of a rectangle are equal to each other. So the opposite sides in rectangle MOAL must be equal to each other. That is to say, MO must be equal to AL. MO must be equal to AL. But MO equals to 2 units. It is the radius of the circle. MO equals to 2, so for this equation 2 equals to MO equals to AL, we'll derive that AL is also equals to 2 units. AL equals to 2 units. Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, we get that MA equals to OL. MA equals to OL and O, but we know that OL equals to 2 units. It is the radius of the circle. Here, OL equals to 2 units. And from this equation, MA equals to OL equals to 2, we derive that MA is also equals to 2 units. Here, MA equals to 2 units. So we found out that all the sides of quadrilateral MOAL are equal to 2 units. Therefore, quadrilateral MOAL is not a rectangle but a square. Quadrilateral MOAL is a square. Then I presented to you rule number 2. According to rule number 2, the lengths of two tangents from a common extra point to a circle are equal. So we'll focus on the common extra point E. From the common extra point E, we have two tangents to the circle, tangent EM and tangent EZ. And according to rule number 2, they are equal to each other. EM equals to EZ according to rule number 2. What is the length of the tangent EM? The length of tangent EM is equal to DA minus DE minus MA. Again, EM equals to DA minus DE minus MA. Again, EM equals to DA minus DE minus MA. DA equals to X according to our definition. D equals to 1 unit according to what is given as the question, and MA equals to 2 according to what is already found out. So in conclusion, I found out that EM equals to X minus 1 minus 2, that is to say EM equals to X minus 3. We found out that EM equals to X minus 3, but according to rule number 2, from one side we have already found out that EM equals to EZ. But from the other side, we just right now found out that EM equals to X minus 3. So from this equation X minus 3 equals to EM equals to EZ, we derive that EZ is also equals to X minus 3. Here, EZ equals to X minus 3. Then we focus on the common extra point B. On this point, the common extra point B. This point B. From point B, we have two tangents to the circle. The first tangent is tangent BL, and the second tangent is tangent BZ, and according to rule number 2, they must be equal to each other. That is to say, BL must be equal to BZ according to rule number 2. What is the length of tangent BL? From the drawing, it is very easy to see that BL equals to BA minus LA. Again, BA minus LA equals to BL. BL equals to BA minus LA. So BL equals to BA, that is X. BA equals to X. Minus LA, that is 2 units. So in conclusion, I found out that BL equals to X minus 2. So from one side, we know that BL equals to BZ according to rule number 2. But from the other side, we just right now found out that BL equals to X minus 2. So from this equation, X minus 2 equals to BL equals to BZ, we derive that BZ is also equals to X minus 2. Here, BZ is also equals to X minus 2. And what is the length of AE? The length of line segment AE, from the drawings it's very easy to see that AE equals to DA minus DE. Again, AE equals to DA minus DE. EA equals to DA minus DE. So EA equals to DA, that is X, according to our definition, minus DE, that is 1, according to what is given as the question. So in conclusion, I found out that EA equals to X minus 1. Then I copied triangle EAB, the right triangle EAB, in this new page, and we implemented the Pythagoras theorem on this triangle, triangle EAB. According to the Pythagoras theorem, we get that in triangle EAB, first of all, we just right now found out that EA equals to X minus 1. AB equals to X according to our definition, and the hypotenuse EB equals to X minus 3 plus X minus 2. Here, so EB equals to X minus 3 plus X minus 2. X minus 3 plus X minus 2 is X plus X is 2X, and minus 3 plus minus 2 is minus 5. So in conclusion, I found out that the hypotenuse AB equals to 2X minus 5. Okay, then we implemented the Pythagoras theorem on this right triangle, triangle AB. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is EB, so the square of the hypotenuse is EB square, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to EA square plus AB square. So EB equals to 2X minus 5. Therefore, EB square is 2X minus 5 square, that it is equal to EA square. EA equals to X minus 1, so EA square equals to X minus 1 square, plus AB square. AB equals to X, so AB square is X square. In conclusion, we found out that 2X minus 5 square equals to X square plus X minus 1 square. We open the brackets on both sides of equation number 1, and we found out that 2X minus 5 square, it is equal to 2X squared, 2X squared, that is 4X squared, plus 5 squared, that is 25, minus 2 times 2X is minus 4X, and minus 4X times 5 is minus 20X. And it is equal to X minus 1 square. X minus 1 square equals to X squared plus 1 squared, that is 1, plus minus 2X, and we have to add to it X squared. So in this side of the equation we have 4X squared minus 20X plus 25. In the other side of the equation we have X squared plus X squared, that is 2X squared, minus 2X plus 1. We subtracted 2X squared from this equation, equation number 1, and found out that 4X squared minus 2X squared is 2X squared. 2X squared minus 2X squared is 0. We added 2X to this equation, equation number 1. So 2X minus 2X is 0, and minus 20X plus 2X is minus 18X. We subtracted 1 from this equation, equation number 1, and found out that 25 minus 1 is 24, and 1 minus 1 is 0. So in conclusion, we got the quadratic equation that 2X squared minus 18X plus 24 equals to 0. We divided this equation, equation number 1 by 2, and found out that 2X squared over 2 is X squared, minus 18X over 2 is minus 9X, plus 24 over 2 is 12. So in conclusion, we got the quadratic equation that X squared minus 9X plus 2F equals to 0. In this quadratic equation, the coefficient A equals to 1, the coefficient B equals to minus 9, and the coefficient C equals to 12. And the general formula for solving out the quadratic equation is X equals to minus B plus minus square root of b squared minus 4 times AC over 2a. So here x equals to minus b equals to minus 9, so minus b is minus 9, that is plus 9, plus minus b squared. B equals to minus 9, so b squared is minus 9 squared, that is 81. Minus 4 times a is 1, times c is 12. Over 2a. A is 1, so 2 times 1 is 2. So we found out that x equals to 9 plus minus square root of 81, and minus 4 times 12 is minus 48 divided by 2. So x equals to 9 plus minus 81 minus 48 is 33. So inside the square, the root, inside the root we left only with 33, or divided by 2. So x equals to, here we have two solutions that are possible for x. The first solution for x is x equals to 9 minus square root of 33 over 2. So 9 minus square root of 33 over 2 is 1.62. So according to the first solution for x equals to 1.62 units. So here AB that is equal to x, it is equal to 1.62 units. But you can see from the drawing that x is longer than AL, and AL equals to x. And because of the fact that x is longer than AL and AL equals to 2, it means that x must be greater than 2. From the drawing, it is very easy to see that x must be greater than 2. And here x that is equal to 1.62 is less than 2. And x must be greater than 2, therefore this solution is incorrect solution. We cancel the solution and we left only with the second solution, that x equals to 9 plus square root of 33 over 2. Or in terms of numbers, it is equal to 7.37 units. Here, the side length of square ABCD equals to either 9 plus square root of 33 over 2 units, or in terms of numbers, it is equal to 7.37 units. We finish with the first question. Then I present to you the second question. We solve the second question in two different methods. In the first method, we have here triangle ABC, side BD equals to 2 units, side AB equals to A, side AC equals to 2A, angle BAD equals to 60 degrees, angle DAC equals to 60 degrees, and we want to find out the length of side AD that is equal to x. Okay, so first of all I presented to you the angle vector theorem. According to angle vector theorem, that is true in any triangle. Triangle ABC could be any triangle. Here we have AD that is the angle bisector. Why AD is the angle bisector? Because of the fact that it divides angle BAC into two halves. Each half equals to theta. So here we have the angle bisector AD, therefore we can implement the angle bisector theorem in this triangle. According to the angle bisector theorem, the following equation is true, that AB over AC equals to BD over DC. Again, AB over AC equals to BD over DC. Implemented the angle bisector theorem in triangle ABC. Why can we implement the angle bisector theorem in triangle ABC? Because of the fact that triangle ABC has the line segment AD that is the angle bisector. AD is angle bisector because of the fact that it divides angle BAC into two halves. Each half equals to 60 degrees. Therefore, we can implement the angle bisector theorem in this triangle ABC. According to angle bisector theorem, we get that AB over AC equals to BD over DC. Again, in triangle ABC, AB over DC equals to BD over DC. AB equals to A, AC equals to 2A, BD equals to 2, and DC is the missing line segment, so we leave it as it is. Here we have A in the numerator and A in the denominator, so A will get cancelled, and we left only with 1 half that is equal to 2 over DC. Because multiply this equation number 1, and found out that DC equals to 2 times 2. That is to say DC equals to 2 times 2, that is 4. So we found out here that DC equals to 4 units. Then we did a construction. We extended side CA by a straight line, and from point B we raised perpendicular to the extended CA. So this angle equals to 90 degrees according to our construction. Okay, and repeat again that angle BEA equals to 90 degrees according to our construction. Okay, so actually CA is one side of triangle ABC, therefore it is absolutely a straight line. We extended the straight line CA by straight line, and the result is EC. When we extend a straight line by straight line, the result must be a straight line, so the result that is EC, it is absolutely a straight line. So you can write here that EC is a straight line, and we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the straight line EC, if we focus on the lower side of the straight line EC at point A, then the sum of the angles here must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of EC at point A? We have here 60 degrees, plus 60 degrees, plus angle BAE. In total, the sum of those three angles must be equal to 180 degrees according to the rule that I mentioned. So your 60 degrees plus 60 degrees plus angle BAE must be equal to 180 degrees. 60 degrees plus 60 degrees is 120 degrees. So 120 degrees plus angle BAE equals to 180 degrees. We subtracted 120 degrees from this equation. We found out that the missing angle BAE equals to 180 degrees minus 120 degrees. It is 60 degrees. So here the missing angle here is 60 degrees. Okay. Then we focus on the right green triangle, triangle EAB. In this green right triangle, we know that cosine 60 degrees equals to EA over BA. The right green triangle, triangle EAB, cosine 60 degrees equals to EA over BA. So it is EA over BA. BA equals to A, according to what is given us the question. So we can substitute BA by A. So we did it, and we got that cosine 60 degrees equals to EA over A. Cosine 60 degrees equals to 1 half. So we substitute cosine 60 degrees by 1 half, and we got that 1 half equals to EA over A. We multiplied this equation by A, and we found out that EA equals to A over 2. Here EA equals to A over 2. Then we continue to focus on the right green triangle, triangle EAB. And so in the right green triangle, triangle EAB, we know that sine of 60 degrees equals to EB over BA. Sine of 60 degrees is the right triangle EAB equals to B over BA. BE equals, so it is BA over BE over BA, but BA equals to A, so we substitute BA by A. And we got that sine of 60 degrees equals to BE over A. Sine of 60 degrees equals to square root of 3 over 2, so we substituted sine of 60 degrees by square root of 3 over 2, and found out that square root of 3 over 2 equals to BE over A. Here we multiplied this equation by A, and found out that B equals to A times square root of 3 over 2. Here B equals to A times square root of 3 over 2. Then we implemented the Pythagoras theorem on the right green triangle, triangle EBC. So I copied the right green triangle, triangle EBC in this new page, and we implemented the Pythagoras theorem on this triangle, triangle EBC. What is the length of EC? EC equals to 2A plus A over 2. 2A plus A over 2 is 2.5A, and 2.5A is 5 over 2A. We already found out that EB equals to square root of 3 over 2 times A, and the hypotenuse DC is 2 plus 4, that is 6. So implemented the Pythagoras theorem on this right triangle, triangle EBC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. the hypotenuse is BC, so the square of the hypotenuse is BC square. It must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to EB square plus EC square. So in conclusion, found out that according to the Pythagoras theorem, BC square equals to BE square plus EC square. BC equals to 6, so BC square is 6 squared, that is 36. That is equal, and B equals to square root of 3 over 2 times A. So B square is square root of 3 over 2 times A square plus EC square. EC equals to 5 halves A, so this EC square will be equal to 5 halves A square. We open the brackets on this side of equation number 2. So here 36 equals to square root of 3 over 2 times A square. Square root of 3 squared is 3 and 2 squared is 4 times A square. Here 5 halves times A square is 5 squared, that is 25, over 2 squared, that is 4, times A square. 3 quarters plus 25 quarters is 28 quarters, times A square. So 36 equals to 28 quarters times A square. 28 over 4 is 7, so in conclusion found out that 36 equals to 7A square. We divided this equation number 2 by 7 and found out that A square equals to 36 over 7. Then we took out of this equation number 2 and found out that A equals to 6 over square root of 7 units. Okay. Then I presented to you a new rule, that is rule number 3. According to rule number 3, if we have triangle ABC, that could be any triangle, and we have the angle bisector AD in triangle ABC, then the following equation is true, that AD square equals to AB times AC times BD times again, AD square equals to AB times AC minus BD times DC. Again, AD square equals to AB times AC minus BD times DC. We implemented the rule number 3 in triangle ABC, so I copied triangle ABC in this new page and implemented the rule number 3 in this triangle ABC. According to rule number 3, here in triangle ABC we get that AD square equals to AB times AC minus BD times DC. Okay, AD is x, so AD square is x squared, that is, and it is equal to AB is A, AC is 2A, minus BD is 2 and DC is 4. So in conclusion, we found out that x squared equals to A times 2A minus 2 times 4. A times 2A is 2A squared, minus 2 times 4 is minus 8. So in conclusion, we found out that x squared equals to 2A squared minus 8. And we already found out that A squared equals to 36 over 7. So we substituted A squared by 36 over 7 and found out that x squared equals to 2 times 36 over 7 minus 8. 2 times 36 is 72. And then we multiplied 8 by minus 8 by 7, and then we divided by 7 in order to have a common factor with this expression. And we got that here x squared equals to 72 minus 8 times 7 is minus 56 over 7. 72 minus 56 is 7, so in conclusion found out that x squared equals to 16 over 7. We took out of this equation and found out that x, the missing 9 segment, it is equal to square root of 16 is 4 over square root of 7. So in conclusion found out here that x, it is equal to either 4 over square root of 7 units, or in terms of numbers, it is equal to 1.51 units. X, it is also equal to AD, of course. So we finished with the first method. In the next step, I presented to you how to find out the length of AD that is equal to x according to the second method. Okay, in the second method, we define this angle as theta, therefore this angle must be equal to 180 degrees minus theta. Then I presented to you the law of sines. The law of sines is true in any triangle. So if you have triangle ABC, that could be any triangle. The length of side AC is C units, the length of side AC, the length of side AC is B units, the length of side AB is C units, and the length of side BC is A units. Then according to the law of sines, we get that A over sine A equals to B over sine B equals to C over sine C. We implemented the law of cosines in triangle ABD. In this triangle ABD, according to the law of cosines, in this triangle ABD, we will get that A over sinus theta equals to 2 over sinus 60 degrees. Okay, then we implemented the law of sines in triangle ADC. In triangle ADC, according to the law of sines, we get that 2a over sinus 180 degrees minus theta equals to dc over sinus 60 degrees. And we have the trigonometric identity that sinus 180 degrees minus theta equals to sinus theta. So we can substitute sinus 180 degrees minus theta by sinus theta. We did it, and we got that according to equation number 2, 2a over sinus theta equals to dc over sinus 60 degrees. So here we have, in this side of equation number 2, 2 times a sinus theta, but a over sinus theta, but a over sinus theta according to equation number 1 equals to 2 over sinus 60 degrees. So we can substitute a over sinus theta from equation number 2 by 2 over sinus 60 degrees from equation number 1. We did it, and we got that 2 times 2 over sinus 60 degrees equals to dc over sinus 60 degrees. Here we have sinus 60 degrees on both sides of the equation, so sinus 60 degrees will get cancelled. And we found out here that according to equation number 2, 2 times 2 equals to dc, that is to say dc equals to 2 times 2, that is 4. So we found out that dc equals to 4 units. Here, then I presented to you the law of cosines. We implemented the law of cosines in triangle ABC. What is the law of cosines? The law of cosines is for in any triangle. If we have this triangle ABC, that will be any triangle. The angle between side AB and side AC is theta. Side AB equals to A units in its length, side AC equals to B units in its length, and side BC equals to C units in its length. Then here cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Again, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. We implemented the law of cosines in this triangle ABC, so I copied it from the original drawing. Here, cosine 120 degrees will be equal to A squared plus 2A squared, that is 4A squared, minus BC squared, that is 6 squared, that is 36, over 2 times A times 2A. Okay? So here, cosine 120 degrees is minus 1 half, that is equal to A squared plus 4A squared is 5A squared minus 36 over 2A times 2A. Here we have 2 on both sides of the equation, so 2 will get cancelled. Then we multiply the equation number 3 by minus 2A squared, and we got that minus 2A squared equals to 5A squared minus 36. Then we added 2A squared and also 36 simultaneously to this equation number 3, and we found out that 2A squared plus 5A squared is 7A squared, so 7A squared equals to 36. Okay, and then we divided equation number 3 by 7, and we found out that A squared equals to 36 over 7. We took out of this equation number 3, and we found out that A equals to the square root of 36 is 6, so it is A equals to 6 over square root of 7 units. Then I presented to you a new formula to find out the area of any triangle. So we have this triangle ABC that could be any triangle. The angle between side AB and side AC is theta. Side AB equals to A units in its length, and side AC equals to B units in its length. Then the area of this triangle ABC, it is equal to A times B times sinus theta over 2. Okay? The area of this triangle ABC equals to A times B times sinus theta over 2. then we use this formula to find out the area of this, the triangles here. From the drawing it is very easy to see that the area of triangle ABC equals to the area of triangle ADB plus the area of triangle ADC. Again, the area of the big triangle, triangle ABC, equals to the area of triangle ABD plus the area of triangle ADC. So, we wrote here that the area of triangle ABC equals to the area of triangle ABD plus the area of triangle ADC. So, the area of triangle ABC, according to the new formula, it will be equal to A times 2A times sinus 120 degrees over 2. Again, the area of triangle ABC according to the new formula will be equal to A times 2A times sinus 120 degrees over 2. And it is equal to the area of triangle ABD. The area of triangle ABD equals to, according to the new formula, A times X times sinus 60 degrees over 2. The area of triangle ABD according to the new formula will be equal to A times X times sinus 60 degrees over 2. Plus the area of triangle ADC. The area of triangle ADC according to the new formula will be equal to X times 2A times sinus 60 degrees over 2. The area of triangle ADC according to the new formula will be equal to X times 2A times sinus 60 degrees over 2. Here we have 2 on both sides of the equation, so 2 will get cancelled. And we also know that sinus 120 degrees equals to sinus 60 degrees, so sinus 60 degrees will also get cancelled. And we have A on both sides of the equation, so A will also get cancelled. And what is left from this equation after we cancelled all the variables here? What is left is that in this side we left only with 2A, that is equal to X plus 2X. So 2A equals to X plus 2X, X plus 2X is 3X. So in conclusion, found out that 2A equals to 3X. We divided this equation by 3 and found out that X equals to 2/3 A, 2/3 times A. Then we substituted A by 6 over square root of 7 units. And we got that X equals to 2/3 times A, and A is 6 over square root of 7 units. So here we have 6 over 3 is 2. And we got that X equals to 2 times 2 over square root of 7 units. 2 times 2 is 4, so in conclusion we found out that X equals to 4 over square root of 7 units. So either here we have two solutions, ways to present the solution to this question. X, it is equal to either 4 over square root of 7 units, or in terms of numbers, it is equal to 1.51 units. Okay, I will repeat on the answer. Here, X, it is equal to either 4 over square root of 7 units, so in terms of numbers, X, AD that is equal to X, it is equal to 1.51 units. Okay, thank you very much.